What's up, everybody? We are back for another live stream today. We are going to be finishing up our shopping list, looking at generators, classes, iterators, and maybe even a little puzzle that it's one of my favorite little puzzles to do. So, all right. Thanks for joining us today. If you are new, I am Sam. I am from Python Basics, and Bo and Quincy are, hey Jan, how are you? Allowing me this wonderful opportunity to share my joy and love for Python. So, all right, like I said, I think we're on our 8th. I don't know, Jan. Is this 8th or 9th? Jan helps me stay on task. He's a champ for me. All right, so let's get into what I completely forgot. So we need to start looking at this. So this is how you solve the problem if you have a file that has spaces and you're calling from DOS. It's a double quote. I forgot and I was using a single quote. CodeCamp.py, close that out, and boom. You get your file. So let's look at a couple of problems right here. So we've solved a lot, and I want to add this. I can't remember if I talked about tell or not. What tell does, it is very handy. So if you lose track of where you are, and forgive me for the coughing. I've been trying to treat my throat. Didn't talk most of yesterday. My kids made fun of me. They started whispering, but no, I'm going to try to hang in there as much as I can. I think we can get through everything, and I have a pile of cough drops in front of me. Did some tea and some honey. And even tried letting dark chocolate melt. So, all right, if I cough a lot, I greatly apologize. But, all right, tell. It actually tells you where you are in the stream of the file. So, I have this here. And if you're getting an error, especially then input, output, can't read or write. Yes, it tells you the position where you are in the file stream. So that's actually kind of where I theorize where the term stream came from. It's a stream of data. So when I have an open file, it's in the documentation, it called this open. It says where you are, return a stream. So there we go. So what tell does is it tells you the position. So if you're at the top of the file, you're 0. And then, like if we're going to run this, let's get into it. Let's just stay right here. And then I have it as an Easter egg as please tell. Please tell. So I'm at 71. So one thing that we need to go over is what is happening right down here. So we grabbing our list, our file. We're turning it into a list that we enumerate. Let's bring this back up here. Okay. You guys should be able to see that. Yeah, perfect. So then I'm wrapping this in an enumerator. Then I'm turning it into a list so that I can count it. Then I'm unpacking it, then printing it to the screen. Now what happens is once I choose which one to delete, if I pick a non-zero, then I go back to my list. Sorry, something just fell behind the computer. Hang on one second. Sorry guys, I thought something was back there. Probably something's about to fall. Hopefully it's nothing plugged in here. Alright, sorry about that guys. Would be about right. Okay, so then I go back to my list and I have to, I'm going to then delete something out of the list, and I'm enumerating, so that's why I'm subtracting 1. So I know, because we have to adjust from the user to the file, the user is not going to tolerate this being 0 through whatever number. They're going to want to see 1 through however many. So that's why we're adjusting this to -1. Then we're literally just taking that list and rewriting it to the file. So that's why we go W here. So we don't have to go and get fancy. We're just going to literally reopen the file with W, completely recreate it, write over it, and write our new list. Now, I want to show you this right here. The user will not want to, they're going to sit there, and if they're in this part of their list, they're going to want to maybe delete more than one thing at a time. So we need to figure out how to get that list to come back up. So we're already here writing. So what did I tell you guys how you can do both at the same time? Anybody remember? Alright, so what we're going to do is we're going to add a plus sign. So we can do write and read. So when we write, we are at the end. So basically it's going to be, because as we're writing down, we're putting in, we're inputting, we're at the end of the string, A. We're at the end of the file. So we just wrote, we went to the file. Now we've changed this so we can read it as well. So now what we need to do is come here, and after this, let me make sure this is going to be in the right spot. Yep. So now we need to go file.seek, because we're jumping, we want to jump to the top, and then literally it's just this all again. So it's items equals list. Alright, so since it's the exact same, I'm going to copy it. I know, it's probably going to break, but I don't want you guys to have to be tolerant of. So alright, what did I do there? I did not do tabs, I did control close bracket. And how I knew to do control close bracket is indent region, control close bracket. So then I save this again, then I exit, then I run, so then I list. Okay, then I want to delete shoes, so then I want to delete jelly. So boom, I get the list back every single time after I write it, and then I come back up here and I'm back to the top. So there. Alright, so that wraps that up. So 0 to continue, and then exit. Alright, so now onward to new things. We have wrapped that up. So I hope everybody has had a good week. But yeah, I just always want to appreciate Bo and Quincy for affording me this awesome opportunity. But yeah, if you're new here, I've been studying Python for about seven years and teaching for about 5, and have had my YouTube channel for 3.5. Oh my goodness, almost exactly 3.5 years. So any of these videos, actually, all of this content has already been done once before in micro videos. And I'm not smart enough to come up with that name micro video. One of my subscribers did. So alright, Let's comment this out. And if you're new here, no, but I do look down. Making it. I gotcha. All right, so if you are completely new, highlighter region, Alt, Shift, comments out, everything. And then Alt S, saves. Here's one thing. If you are super, super new, awesome. Glad you're here. But here is a fantastic way to know if you have not, let me see how big that is. If you do not know if you have saved the file. So it's going to have this asterisk up here. And also, you run F5 and it's going to jump because this is going to tell you, hey, you did something. Even if I do one return, it's going to jump up here and it's going to ask me to save again. So there we go. All right. Classes and generators. All right, we're going to go super slow because this can get out of hand really, really, really quickly. Everything in Python is an object. A type of variable, a variable is a class. And so all right. X is an object. It's a variable that 5 is assigned to X, and that type of variable is an int. All right. That's our starting point. That's how we're going to move forward. Okay. Now, let me see. Sorry, I don't know what's happened. I'm falling apart. I'm 43 and everything either hurts. Something always hurts or something's sore or nothing's always working all the time. So, all right, we're going to create an object that's a rectangle. And also let's look at list because this is a great one. So we have dir on Y. So this is what we're going to be doing. Has anybody ever heard the term double underscore? You won't ever hear me say dunder. Have you ever heard of dunder? I'm not just asking. I will never use dunder. But this is double underscore. And let's see. In it. There's iter. So we're going to get into iter. We're going to get into len. We're going to get into repr. And now there we go. And where's string? Okay. These are the things that are happening in the background. And here are methods that we can use. These happen and Python uses. All right. I'll say that again. This is what we use. These are what Python uses. So we're going to create an object. We're going to create our own class rectangle. And we're just going to go from there. Okay. And of course, we're going to use the keyword class. And we need to look at init. Do I have this position right? All right. So init, I thought it was literally in it. This is in it the first time I saw it, but it's initiate. And it uses new. So as you can see, where did we go? Let's close it. Let's shrink that down. New. Boom. All right. There's init. Okay. So new and init all go together. But what this does is how do we create? What do we do to create? How does this object come into existence? So we're going to set the rules of how this object comes into existence. So literally you're creating a brand, think about it as you're creating a integer, or we already know how to use integers and lists and tuples, but now you're creating something new that you're going to need to use that is going to react on its own. You're creating a new object, like a list. You have a list, things can come into it, can come out of it, and you can do things to the list. So here, and when you're creating an object, a class, just these are methods, right? And I said that they act like functions. We know how to create a function. So it's the same structure. You just utilize them with the dot notation method. So the very first thing you have to do is initiate it. Now, this next word can get really weird really, really fast. Self. The best way that I have found to explain this is like this. That Y is a list, but it is its own self, right? So this is, each time you're going to create an object, it is this type, but it is itself. All right. Does that make sense to everybody? You'd only, if you need to, Jan, if you need to, if it's super complicated, possibly, but you wouldn't want to get into any import error. Probably you'd already want that in the file that you'd want to be using, like a Pygame file. You already have that in with your loop. You wouldn't want to have any issues with bringing it in unless it is even a overly complicated or an excessive object. It wouldn't be so big that you wouldn't be able to fit it in the file. And I would, this is reference RE shuffle. You only want to have your own files, because then when you get to having, then we're talking about packages. Not only would you have modules, but then packages. You could, but actually that might be a good lesson for us to get into the double underscore main. Maybe we can do that next time. One important admin note. I haven't gotten to tell Bo and Quincy yet. We are not going to have a live stream next week. I've gotten a little behind a little bit, so I need to take a week off. I'm not going to even have any videos on my channel, so we need to do that. You can, Jan, but I don't recommend it unless it is a super, super complicated item, and then we can go from there. So, all right, a rectangle. Basically, we have the rules of a rectangle: two sides, two sides. So, length, width. All right, so same rules apply. Now, here's where this gets weird. So since this is its own self in this instance, so you have to think of these as their own instance. So we do self.length equals length. All right. So you're bringing this in. You're taking in input. You're then going to assign this to this. I know it feels so weird right now, but am I spelling everything right? Yeah. Okay. So then self.width equals width. Okay. Now we're going to do something. Let's see. Any questions? No, not yet. All right. So let's put this into memory. What do we call this? Didn't mean to do that. Sorry, guys. So much to talk about our shopping list still. But who said it was making them hungry? The shopping list. Yeah, I was glad I was able to get up and Tech. What's up, Tech? Okay. So all right, we have our new X. We just dumped memory. Aha! So it knows to have. We're gonna need to pass in our length and our width. So we're just gonna go 3 by 3. Okay, so then I call. Whoops. So then I call my object. Aha. So right now, we've created it. We've initiated it, but we've done absolutely nothing with it. Now, this is where the programming and the fun starts. Let's just add a little bit here. Print, because I'm going to show you the wrong way, and I'm going to show you the better way. Just to show that we've done something. Sorry. Oops. I really would have bet any amount of money that I muted that. All right, any questions so far? Your rectangle is length by width, and then close that out, save this, boom. So I now have something go out to the screen that our programming user goes, okay, I know something happened, you put something out to the screen, awesome, thank you for doing that. Okay, well, we have a rectangle. We usually want to know stuff about it, right? So now we are going to look at a way. So that Python uses this. Now, why don't we make a method that we can use? All right. Not a big speller, as I'm sure you guys have noticed. So this is going to be short for perimeter. If I start typing perimeter, it's not going to go good. All right. Let's see. So again, I'm using myself. So we're using this. We're regarding the object that we just created, our X, which is a rectangle. All right, and let's see where we are. Oh, okay. So perimeter, it is our length times width times 2. So so let's do that. 2 times self width times self length. All right, let's run this. Boom. So now I want to challenge you guys with something. That is a method. What attributes do we know right now about X? Anybody got any thoughts? And it's fine if you don't, because this was one of the things that threw me off for a very, very long time about difference between an attribute and the method and things like this. So the attributes that I have right now are length and width, and it's just information that is associated. And this is where my self comes into place. The self length and self width taken from here and assign it back to itself. That's why this comes up. I guess I should have done 3 and 4 so we could see to make sure that we did this right. And now my perimeter, so 3 times 3 times 2 is 18. So I did the math correctly here. So now let's do, what's the other one? Area? Why don't we look at area? Def area self, then print. So what? That's just side by side. Self width times self length. There we go. And sorry about the cough drop. Hopefully it's not driving anybody nuts. Okay. Put this back in memory. Hopefully that's not too loud either. So, all right. Yeah, let's change this up a little bit. Make sure we show that we're doing. All right. Your rectangle is 3 by 4. So then we call perimeter 24. Let's check that. Make sure nothing changed. All right, 4 times 2, 24. Okay. So now x dot area 12. So the area is 12 square whatever. Centimeters, square feet, don't know. I guess we did not. Maybe that's something else. And then our x, let's check this. Length, boom, width, boom, perfect. So everything's going pretty good right now. So now let's get into a little bit more stuff. So right now I have my double underscore in it, and that's a cleaner, nicer way to say double underscore. And the reason why it's called double underscore, let's look really, really close. If I can get you the right one. There it is. So 1, 2. 1, 2. Never found in the PEP why it was 2. But that's why it's double underscore, because you literally are depressing and putting in place 2 underscores. All right. So now in our init, we have this. We're getting something out to the screen to share to the programming user that you have created something. And this is it right here. But that's not best practice. I'm going to show you what the best practice is. Something that's called repr. The official string representation of an object. And guess what? It has a double underscore method. And then we're going to go into double underscore string. So, all right. And it's called by the repr function. So if anybody has not noticed this, when you create a double underscore method, it is associated with a method, a built-in Python method. So you're telling Python, hey, when this method gets used, come here and use it. Come in here and do this. All right. So now let's fix this right now. Okay. So we commented that out. So we need to get our double underscore repr. And did anybody notice what I did? I left out a double, or I left out an underscore. All right. And so we stick with self. Sorry, my light seems brighter today, so you can see my cheery face. All right, so this is the official documentation. Excuse me. This is the official string representation of the object. So basically what this is saying is when you call this object back, is what did we do here? What is that? Do we have any idea what that is? I don't. And I don't think you do. All this is saying is we got this. Yeah, we're going to be doing double underscore main soon. That's a cool run through. So it's in that file that you just ran, the main file. It's this object, and it's living in this memory. Other than that, I got no idea. I got nothing for you. Here's the best that I can do for you. But when we use repr, double underscore repr, we're going to tell Python what to put out on the screen. And I want print your rectangle. So when we used this up here, it created and came out to the screen and did this. But let's do it here. Is that where I have it? No, that's not the one. I want that as our, yes, I want that as our string. This is repr. Double underscore string. So, all right. So what I'm doing here is we're going to just spit out this. So let's just show it and then we'll go through it. So before, when I would call our object, our rectangle object, I would get this. So now when I call it, I get, boom, this right here. So I'm kicking out and I'm making this nice, neat, and pretty, and you can use it. Now let's look and see our double underscore str. Now this is where it gets, all right, str, called by string object with built-in functions format. So it is the informal or printable string representation of objects. So if by chance you did not have a double underscore repr, it would come down here and pull the string. So let's do this, because this is where this should go. Double underscore str, double underscore self. And then is this return? Yeah, this is return. Oh, we got to put it in memory. So when we call, let's go over this real slow. So when these are called, as you go through and and we'll see this in a second when we get to iterators and generators. All right. So the built-in functions that Python has done all this tremendous work for us. When you want to interact, when you have an object, when you want to interact with those functions, this is how you do it. All right, I haven't clicked over and looked at chat in a while. Yes, that is the memory RAM address. That is exactly it. Yes. Actually, that would be something that we can do, because I do want to get into is and because you can get very lost into copy very quickly. So yes, but that is the memory address location, how to deal with those. But yes, you're correct. You're absolutely correct, Jan. Jan's always got good questions. That is the RAM address on your system. All right. I digress. I can get sucked into this so quickly, but you guys are absolutely awesome and absolutely awesome. Ask awesome questions. All right. But this is how you interact with Python. This is where you begin to control and have the program user get what they need out of it. So when they are using functions, this is how you control what comes out to the screen. All right. So we're 35 in. Oh, we have got to touch on inheritance because that gets very cool very quickly as well. So, all right. So right here, we just created a really simple object. Let me get this. Hopefully I didn't drop this that bad. So we created a little object. Takes in 2 arguments. And then we know how to use, well, create it. Then we know how to use and interact with the repr and the string built-in functions for Python, creating and using our double underscore methods, repr and double underscore string. And then created 2 new methods, or 2 methods for our object. So where Python gets very, very powerful very quickly is called inheritance. And what that is especially when you're wanting to borrow, I'll give you a perfect example of something, and hopefully we're still working together and we can touch on it. But you don't want to create a new object. You just want to bring one in and either shrink it or expand upon it. Typically, you'd expand upon it. I don't know why I said shrink it. But you go, okay, I like everything about this, but there's a couple more things I'd like to do with it. So you bring in this object, and then you just add some. So we're going to... Sorry, I think I have a delivery, so hopefully my dogs aren't going to go too nuts for you. All right, so we're going to deal with a species, dog, and then jump into breed. So we go class, dog, species, let's see if I spell this right, canine. So I'm going to, then we need to talk about what I'm, there we go, what I'm doing right now. Voice, and they bark. All right. So now what I'm doing here is I'm hardwiring. So right now I don't have anybody interacting with any part of this. I'm just creating these attributes and I'm hardwiring them in. So now when I do, let's say, Buster, and he's a dog. Boom. Buster. So there's my object, and Buster is did I spell that right? Oh, I didn't even know. Yeah, sometimes. Okay, so he's a canine, and then Buster's voice, he barks. Now, this is where it gets cool. All right, so now if I bring in, and I want to do, so what, a breed of a dog, poodle. So I bring in dog. I'm going to inherit, and I don't know if we talked about pass before, keyword pass. Basically, it's telling Python, hey, I know I got some stuff here. I have some indentation. Just go ahead and ignore it for now, and I promise I'll fill it in later. Sometimes you don't have to, but it'd be odd if you had it there and didn't fill it in. So now we have Rusty. He's a poodle. Oop. Did I not put that? Nope. Here, check this out. So how did I make that mistake? Right here. Came up here. So of course poodle's not in memory, right? Because I didn't save it. Rusty. Now I didn't pass anything into, all I did was come up here and say go and grab everything. Throw it into Poodle. Rusty. Then his voice. He barks. And then Rusty dot, you already see where this is going. Species. He's a canine. So, all right. These are the building blocks, and I want to let this sit and go from there. And I'll just give you a little tease. So when you're building, so it took me a while to understand how something can happen. So think about a character in a video game, or even a block that's just sitting there. And yeah, how about we keep this? Sorry, a bird just flew into my window. Glad I didn't yell. So instead of doing functions, so this is the beginnings of object-oriented programming, OOP. You and I we've been interacting with functionality, functional programming. Lots of functions doing things. This is the building block where you set rules, and when an input happens to this object or an event, you have all of these scenarios and conditions. And then, so like if you have, let's just go with the block. So if it gets hit with another object, you have rules for that and methods that then go from there, and things happen. Then when you get more complicated, you have a character in a game. You press the up button, they do something, they'll move forward. And now with games sophisticated, you're going to need to then have the shoulders move, maybe the head, the torso, and all of these things. But instead of going through and having to think of all these scenarios, you create an object, then that's the player, then you create a player off that object, just like we do strings. So just like I could do, let's bring this back. This is a perfect time to do this. So I have my X, let's keep this here. Then I have my Y. And you're getting the idea. That's exactly, but it wouldn't be quite as, each input would have its own, and then you don't have to think about it. So as you're looping through, like here's a perfect example with Pygame. Update. So as you run the update, you have an update method for that object. So each time through, if something's happening, if this condition is met, do this. So then I have Y, and this is going to be 2 by 6. So I have Y and X, two separate rectangle objects that are acting independently from each other. So, all right. My voice is already fading. So let's try to get through. I want to get through our puzzle. I want to get through iterators and generators. So, all right. I know this can get very complicated very, very quickly. Let me get a cough drop. Hope I haven't been hacking too much for you guys. No, I love this stuff. It's crazy to me that it's still going down to a processor either having power run through it or it's closed. Still blows my mind how sophisticated we've come from a light lighting up or not. Okay. There we go. I could talk about this forever. Okay, so we need to talk about iterables and iterators. Does anybody have any idea the difference between the two? So you iterate through iterable objects. So iterators and iterables are like your hand. All right. All iterables. Nope, I haven't said this in a while, so I'm going to mess this up. So you can iterate through iterables and iterators, but not all iterables are iterators. Let's look at it. So here is a perfect example of me turning an iterable, and we're going to build upon it, and we're going to look at it. So name Sam. So put this into memory. Then we call dir on name. So I want you to look. So we got our init, iter. Oh, okay. Get an iterator from an object, callable, iterable. So I can go through this because they act the same, but they are not the same. And the main difference is the next function. So I like to lead iterator into generator. All right. So an iterator uses the next and double underscore. All right. So right now, I do not have a double underscore next. So watch. So now for whoa, that's how many times I type that. Then print I. Boom. I get Sam. I don't know why the birds are so active today. All right, so now let's wrap this up. It's an iter object. So now let's run dir on name. So we're going to get into it. We're going to get sophisticated really, really quickly after this. And one of the things that I love to do, and I just don't want to jump into the time module. I like to let this stuff sit and percolate, and then we go from there. So basically the main difference. Whoa, wrong way. It's okay. Because you can iterate over an iterator and an iterable. All right. Because it has next works. So now we need to look at next. This is how you go through. Return the next item from an iterator. So where these become very powerful is, let's say when you have a command and you want to go through a iterable, but you don't want it to happen all at one time. You just want to go through it. So let me put, so now this is exhausted, so I need to turn this off. So I call name. So there is my iterator object. Then I call next on name, next on name, next on name. Then I call next on name one more time, and it is exhausted. So, all right. So now that is our foray. This is our warm up to a generator. So what a generator does, and the reason why generators are so very powerful, is they don't use up memory. So again, when we do our time, and I'm going to show you, and they're fast. They're ridiculously fast. So they're just sitting and waiting to be used. It's almost like they have a set of instructions, but they haven't created anything. That's the best that I've come up to explain it. They're a set of instructions, and they just go and do it when they need it. They haven't created anything. They just know what to do. They go and touch it, come back, and just wait for the next one. Kind of pun was intended. I thought I'd get, well, you guys just have to sit there. But I have a very captive audience. I have a very awesome audience. You guys are absolutely awesome. So yeah, I think we can get to at least 75 minutes because we're going to do generator. Then I'm going to show you a little puzzle that I love to really get people to think about, especially newer programmers, of how to set up a rule of instructions. Because you saw that with our list here where we were bouncing around and you had flow. All right. I digress. Sorry, guys. Okay. So a generator. What in the world is a generator? So basically a generator is something that has a set of instructions that is sitting out there and waiting to be done. So, all right. Seeing a jump up here. So if you guys are new here, thanks for joining us today. I am Sam from Python Basics. This is our 8th, 9th stream, and we are going through the absolute basics of Python from the beginning, heading towards intermediate, and the sky's the limit. So all of these videos are all the previous live streams are in a playlist on freeCodeCamp. Every single topic that I have done here are in micro videos on my channel in the description down below. All right, that's a little admin right there because I did see that it went from about 200 to 250. So I know sometimes I can get all wound up and fly through some stuff. Generators. And very soon we will show a awesome example. We haven't really messed with modules that much, but time can be a very tricky one, and so I just want to introduce you guys to generators, and then we'll go from there. So let's look at this. And the difference in the keyword, so we know that return is with a function, and literally how you go from a function object to a generator is it, where was it? Yeah, iterator object, and this is how you then are going to turn these into a generator. So n equals 0, then while n less than num, yield. Now, how did I know I spelled that wrong? You guys could look at it and see. My word. Because it didn't go orange. Then n plus equals 1. Boom. Then 5 equals series. I'm going to do this the short way. We'll just do 3. So I'm creating a, well, I should at least do that since I'm calling it 5. I realized that I complained about this when I did it. So 5, okay. Generator object series at this memory location. Well, Jan, you know what? I really appreciate that note. Jan is absolutely correct. Everything, I'm a huge believer in trying to be very thorough and also building upon the next. Because look, I want you guys, all right, a little side note. I remember somebody told me, well, you just need to be more confident. Go get some confidence. Like, what does that mean? How do you just go get some confidence? All right. I want you to do these little skills, these little building blocks. I want you to know how to do it. I want you to have success. Success and confidence they're the same. So I want you to be able to build these things, these little things. Have success building these things. Get confident building these things, and then become more confident. one of the coolest things that I get to do is read the comments of these huge programs, these lines of code that people write because of the things that I showed them. That's probably the coolest thing that's part of all this. So Jan, that is a great shout out. If you're seeing this for the first time, if you're seeing me for the first time, thanks for being here. Do not be intimidated. Just a side note to remind everybody, I started learning to program when I was 36 years old. I'm dyslexic, can't type, can't spell. I have ADD. If I can do it, anybody can do it. Okay? That's just type code. Follow along, go back, rewatch them, do it again. All right. Awesome shout out, Jan. Thank you so much. Okay. So now let's run dir on 5. Boom. So then I do next on 5. I get 0. I go next on 5. I go 1. Next on 5, 2. Next on 5, 3. So where should this exhaust? Boom. 1, 2, 3, 4, 5. Now we could have started at 1 and gone through, but I have 5 objects in, and we're gonna expand upon this, and we're gonna go from here. But this is our introduction to objects, generators, iterables. So now, all right, so we're at 56. We're going to do a cool little puzzle to get us to think of patterns. I love going back to this. So if you guys haven't seen this, I got to draw my little sad little stick figure? I think so. So a guy, a robot, whatever, standing here. He's got a bobblehead. So he's got to walk and go through here. So how can he touch all 9 circles with a repeatable pattern? And this was one of the first ones that I saw and that I liked in my kids' class of how that they had to solve this. Everything else was open for interpretation, but I thought it was great for loops. So here's a set of instructions to touch all of these, and then you can put that one set of instructions into a loop of 3. So go forward, go all the way down, turn 180 degrees, come all the way up, turn to the right. Boom. Completely repeatable. So step forward, turn to the right, go forward 2, turn 180 degrees, go forward 2, turn to the right. You're literally in this position right here. So that loop you can repeat then 2 more times. So literally those set of instructions you would do 3 times. And I want you to think about it. We did that with our loop right here. We're coming through, we're setting down, and then we solved this problem down here where we loop back through and turn that into a plus. So here is the puzzle that we're going to do right now. And I think it's a great example, and especially to get us to think of how to solve this and be very concise, and we're gonna be exposed to a new keyword. So the puzzle is round to the nearest 5 if, so it's a grading scale. It's a math puzzle for programming, and the teacher wants to round up 2. So if a kid gets, if a student gets a 78, it'll round up to a 80. If they get a 77, it stays a 77. So if it is within, if it is within 2 of the next 10, so if it is then a 90, so would that be a 93? 93, it rounds up to a 95. Now we could do this longhand and have every single one of these scenarios But that's not Pythonic. That's not programming. That's not concise. That's cheating. So this is a great mental exercise and recognition of a pattern. That's what this is. This is a recognition of a pattern. Forward, turn right, turn 180 degrees, one way or the other, go forward 2 more, turn to the right again. Repeatable, consistent, concise. 5 sets of instructions repeated 3 times. So here's our dilemma. So this is what I want you guys to think about. So if it was a 72, it would stay a 72 because it is not within 2 of the next 95. Now if it was a 74, which these would be my grades when I was in school, 74 would be rounded up to a 75. All right, so let's get into it. So first we're going to take in, so we need to figure out how we're going to do this. Are we just going to take the function? So let's just take in a function, or we're going to call it 5s. Now we need to think about this. How can we then get what information do we care about? We care how close, where it is, what it is, how close to the 5, right? So we need to start examining. Let's bring this down. All right, I think that's good. Am I still within frame? All right. Okay, good. Let's bring that up a little bit. Yeah. Okay. Pass. So we're going to start. So if I only care about a number if it's close to 5. Well, wait a second. If it's close to 5, I'm going by units of 5. So what tool do I have to keep up with counting by 5s? This is a perfect example. How do we find out if something was an even or an odd number? Jan, do you remember how we did that with even or odd? Because basically we were counting by 2s. So now we're going to be counting by 5s. No, I never tested to see how delayed the module. Oops, I almost said it. Modulos. Bingo. So 74 divided modulo 4. Excuse me, modulo 5. Get a remainder of 4. So let's do this a little longhand. I'm a huge fan of longhand until we begin to see what a pattern is. So 74 would be rounded up to 75. 72 modulo 5 would, 72 modulo 5 is a remainder of 2. So that wouldn't get rounded up. But 73 modulo 5 would get rounded up. So let's look on the other side. So let's do, 88 would be rounded up to 100, right? 98 and 99 would both be rounded up to 100. So wouldn't get rounded up, would get rounded up, would get rounded up, would get rounded up, would not get rounded up. Anybody noticing the pattern yet? So when would Anybody see it yet? So basically, if my remainders are 3 and 4, I will round up to the next 5. So we're going to do this a very long way, and then I'm going to show you a very cool concise. So we got if x modulo 5 equals x plus equals 1. So that is absolutely very, very true. You can just put your head down and whatever the assignment, whatever the workload is. So all right. So if it's 5, we know we're going to have a remainder. If the remainder is 4, we know we're going to need to add 1 because what? We're rounding to the next 5. So let's look at this really close. And then elif x modulo 5 3 x plus equals 2. So how did I come up with 2? 2 and 3 equals 5, rounding up to the next 5. So if I come here and I test, so if I have a list, grades, what, 72, 98, 94, 83, 71, 73, and 100. Let's see if I did this right. For grade in grades, fives, grade. So 72, actually, let's get fancy. I haven't done that in a while. Does that work? You have to forgive me, I haven't tested any of that. There we go. There we go. So, shouldn't have rounded, 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 shouldn't have rounded, rounded, and shouldn't have rounded. So there we go. Now, bingo, they add up to 5. So let's get fancier. Let's get a little bit more logic based. So we're still kind of manually manipulating this because we're still going through and doing math. But what is a more concise realization of this pattern? And we're going to learn who's used or, keyword or. I was just thinking about that. We need to do one for and. and it's eluding me right now. Okay, I know I have one. But who's seen the or keyword? Anybody? Jan? Okay. All right. This is where it gets really, really concise very, very quickly. So I can put this all on 3 lines. I can put all this on 3 lines. But it's just thinking through the problem, thinking through the pattern. 5 equals 3. Or, so this being true or this being true. So we're going to look at this. 1 equals 1 or 1 equals 2. True. So 1 equals 2 or 1 equals 3. False. So right. It only has to have one true. And has to have both or all. Ooh, yeah, we need to do all. We need to do and, any, and all. I need to make a note of that. Hang on, let me do that now. For 2 weeks from now. And, all, any, and time. We'll do time. All right. So, where are we? All right, we're boiling this down. Or x modulo 5 equals 4. Right? So it's this scenario or this scenario. Now, here's where the math gets really fun. And this is the math that I love to do. All right. No. Look, you guys are doing phenomenal. I forget who was saying that they had already done a bot. I don't care about jargon. I don't care if you use the right jargon or not. I mean, if you have the underlying concept, yeah, that's exactly it. Having the jargon and typing exactly right, that's practice. Understanding how to lay these out, that's the important part. You can go and Google where to use it, but if you don't know what to use, it's pointless. That you don't have to remember any of this. There have been so many times I've gone back. That's why you never delete anything. Don't ever delete anything. Just comment it out, or shove it over and comment that out. Do a new one. Just go back, and it's for a variety of reasons. One, it's a resource that you have that you've already done, and a problem you've already solved that you can go back and look at. 2, it's to then also see the development that you've done. So, all right, let's do this and start wrapping it up because my voice is fading fast. I like that. Yes, if you guys don't know the Zen of Python, make sure you look at it. Let's do this. Jan, you remember how to bring it in? Boom. Zen of Python. It's literally that. Import this. Yep. Bam. Bingo. All right. So now let's clean this up, make this very concise, just like our picture. Well, not my picture, but the concept. Forward, turn right, go forward 2 more, 180, right or left, forward 2, turn right. Boom, you're done. Repeat those instructions 3 times. All right. Let's see, bring this down. So now, what pattern have we noticed with this? So check this out. X plus equals 5 minus x modulo 5. So if it's off by 4, we add 1. If it's off by 3, we add 2. So as long, we just want these to equal 5, right? So that's why this modulo, if it equals 3, we subtract that 3 from 5, we get 2, we add 2 to x. If this is equal to 4, 5 minus this would be 1. We only add 1. Print x. So boom. And helps if you use the correct. Boom. Same output. Exact same output. Not move, should move, should move, should move, not move, should move, not move. So boom. So there we go. This is probably one of my favorite puzzles. Well, I got a couple. I love the chicken nugget one from the MIT puzzle. Have we done that yet? Jan, have we done the finding chicken nugget combinations yet? I know we did nth prime number, and then we did, what was our decorator? We did a nested function for, can't remember what it was. But this is one of my favorites. The chicken nugget count is one. If we haven't done that, I'll go back and look at the notes, I guess. Well, I guess I can look right here. Chicken. No, we haven't. And then also second conversion. So we're going to do all these. So I'll sprinkle in these puzzles in between the concept for our Python. So I appreciate everybody, and to remind everybody, we will be off next week. We'll rejoin in 2 weeks. Be a great time to go back and catch up. Watch the previous live streams. Bo's done an awesome job. They are sitting in their own little playlist. You can go back and watch all of them, any of them, and any concept that you can't remember which stream it was in. You can jump back over. And I really like to rounds of I gotcha. Any of these concepts that or items in here, I have a single specific video for every single topic that we've ever done here. So if you can't remember what live stream it was, jump over to my channel, do a search for it, it'll jump right up. But I just want to tell you guys, thank you. I greatly appreciate all your attention, all your questions, and all your awesome support. And I will see you guys in 2 weeks. And always, thanks again, guys, and we'll see you guys next time. Bye.